This project aims at using time series to predict the dollar's rate in different countries. Firstly, I will use the table reader to load an outside file into the workplace. After that, I'm going to change the time string into a new format. In the configuration, there are four parts needed to fill in. Firstly, select the column which needs to be converted. Secondly, choose whether the old column should be remained. Thirdly, enter the new name for the column if the old one does not need to be replaced. Finally, choose the new data format. You can see there are many formats for the time. So after that, you can see the result. There are different dollars rates for different countries, and this column means the time. After that, I'm going to extract the data from only the year 1985 to the year 1995. In the configuration, I can choose the start point 1985 and the end point 1995. In the result, you can see there are only about 2,869 rows. And after that, I'm going to normalize. Since the ranges of dollars rates are different, so I'm going to use a linear transportation to normalize the different dollar ranges in a table into a uniform range 1 to 0, 0 to 1. So in the configuration, I will use the method min-max normalization, and I will set the bounds, the min to 0 and the max to 1. So after the linear transportation, you can see the results. All the dollars rate for different countries has been converted between 0 and 1. And finally, I'm going to plot this data on the image. I set the time slot as an x-axis, and in the picture there are 8 different colors. Every color can represent the country, so you can see the different dollars rate for 8 country, and the range is between 0 and 1. For the next goal, I'm going to predict the dollars rate. So here, firstly, I'm going to extract the year and quarter field in the configuration. I'm going to choose the year and quarter as 2 new columns. So you can see from the result there are 2 new columns, year and quarter. These 2 columns are extracted from this column, the time. So after that, I'm going to aggregate. It means I will, for for every city, I will choose in the configuration, I will use the method mean to calculate the mean values for every quarter in every year. So I can, after this function, I can get a new table. In this table, there are only 17 rows, and for every city, and in 1 year, and there is a mean value for the dollars rate in this quarter instead of 1 day. It's more simple. After that, I'm going to focus on the dollars rate in one country. So in the configuration, I'm going to filter the data and choose the data for Switzerland. So you can see the results in the filtered table. There is only the um, information left about the Switzerland. So after that, I'm going to calculate the moving average. The moving average can stand for the trend of the dollar's rate. After the calculation, you can see the results. There is a new column, the moving average. It means it can stand for the trend of the dollar's rate. After I have filtered out some missing values, I'm going to use a small Java snippet to do some calculation. In the Java snippet, I'm going to use a function called math to calculate the difference between the mean values and the moving average. This result can stand for the change or say the trend of the dollar's rate at that time. So you can see the result appendix table. There is a trend. It's the difference between this column and this column. After that, I'm going to format the results. I'm going to convert the time back into the string format, and I'm going to change the row ID. So finally, I'm going to plot the results. You can see in the result there are 3 lines. For the blue one, it means the trend from this year to this year, and the red one stands for the mean values of the dollar's rate, and the green one stands for the moving average. It is the change of the dollar's rate. So from this picture, I can predict the trend of the dollar's rate of Switzerland.